So continuing on with 5.2, we have a general addition rule for the keyword or. Okay, so what's going to happen is we're going to have two formulas for the keyword or. One, whenever events are disjoint, and two, whenever events overlap. Okay, so whenever events overlap, and if those events are joined with the keyword or. Okay, this is what we're dealing with as far as the Venn diagram goes. Call this event A, and both event A and B actually have some overlapping outcomes of interest. Okay, so if you have this Venn diagram, this is the formula we need to use. The formula for A or B, okay, that's equal to the individual probability plus probability of B, but what we'll do is we'll subtract an overlap. Okay, and an overlap in mathematics, we call that probability of A and B. Okay, so this is the formula that we'll use when it comes to the keyword or if events overlap. Okay, so let's look at example 2. Example 2 says, in a sample space containing elements 0 through 10, let A be the event, choosing a positive single-digit odd number. Let event B be a number less than or equal to 4. What we'll do is we'll draw a Venn diagram, and we'll draw one number at random and find the probability of A or B occurring. So let's first define in example 2 the sample space. Okay, so for the sample space, that's going to be 0 through 10. Okay, now notice events A and B now. So for event A will be the event of interest, choosing a positive single-digit odd number. Okay, so from the sample space, we take 1, 3, 5, 7, and 9. And notice we don't continue 11, 13, 15, because the sample space is a universal set. Those are all possible outcomes, so the events of interest have to come from the sample space. And then let's look at B. Okay, B says a number less than or equal to 4. So from the sample space, that would be 0, 1, 2, 3, and 4, right? And what you'll notice with A and B, they actually have overlapping elements. They have overlapping outcomes, right? So whenever we want to draw the sample space, this is what the sample space will look like. Okay. So we draw a Venn diagram here. Okay. So the two events will overlap. The overlapping outcomes we determined were 1 and 3. Is that right? Okay, let's double check. Okay, so 1 and 3 were the overlapping outcomes. Now for event A, suppose this is event A, this first circle here. Event A should still have 1, 3, 5, 7, and 9, right? So keep in mind, this is the entire event A right here, this entire circle. It has to have 1, 3, 5, 7, and 9. 5, 7, 9 we can place still inside the circle, but not in the overlap. Okay. Suppose this is event B. When we look at event B has to have 0, 1, 2, 3, 4. So this entire circle, keep in mind, is going to be event B. Okay, the entire circle is B and already has 1, 3. It still needs 0, 2, 4. So notice how we can read these, the Venn diagram now. Event A should have 1, 3, 5, 7, 9. Okay, let's check in here. This entire circle is event A, and notice it does have 1, 3, 5, 7, 9. Event B should have 0, 1, 2, 3, 4. Okay, and keep in mind, this entire circle is B, and notice the entire circle does have 0, 1, 2, 3, and 4. So this is how we draw the Venn diagram. But now, in part B, we're asked to draw one number at random. Find the probability of that number coming from A or B. So, we have the keyword OR. Okay? And the keyword OR now has two formulas. Keep that in mind. The first formula was when the two events were disjoint. Kind of imagine a Venn diagram with disjoint circles, right? The second formula is this new one now. If you have an overlap, then we're supposed to use this formula right here. So now we need to ask ourselves the same thing here, okay? The question is, do we have an overlap with the two events A and B? Yes, we do, right? That means we need to use this formula here. That's equal to the individual probability A plus the individual probability B minus an overlap. Okay. So now, if you notice, say for example in the sample space, we have elements 0 through 10. So imagine we mark kind of like chips or poker chips with numbers 0 through 10. You put them in a bag, you shake it, and you draw one at random. Each one of those chips are equally likely to be drawn. That's classical probability, right? And if you recall with classical probability, we had a formula. Classical probability is equal to the number of outcomes of interest over the number in the sample space, right? So what we're going to do up here is we're going to do the same thing. Because all outcomes are equally likely, we're going to use the classical rule. So for probability of A, that's the number of outcomes in A over the number in the sample space, plus the number of outcomes in B over the number in the sample space, minus, and this is how we write this one, the number of outcomes that overlap, okay, the number of outcomes that overlap over the number in the sample space. So let's check and see what we get. So for this one, we'll have, let's go down. We can either go to the Venn diagram or we can go here. How many events in A do we have? We have 1, 2, 3, 4, and 5 events. Is that right? So now the number of events of interest is 5 divided by the number of outcomes of interest, right? So the number of outcomes of interest, or the sample space, excuse me, here is going to be S. So this is 1 outcome, 2, 3, 4, 5, 6 outcomes, 7, 8, 9, 10, and 11 outcomes, okay? It's 0 through 10, right? But we do have to count the outcomes here. So there's 11. Okay. Next we have plus the number of outcomes in B. Okay, so we can either go to the Venn diagram, we're back to our list. How many outcomes do we have in B? Well, we have 1, 2, 3 outcomes, 4, and 5 outcomes here. Okay. Divided by the number in the sample space. And we have to subtract the number of outcomes that are in common. So Venn diagram, how many outcomes are shown in common? 2 outcomes, right? Same thing here. How many outcomes are in common? So this is 1 outcome in common here. This is the second outcome in common here. So we have 2 outcomes in common that we're going to do on top, minus 2, out of the number in the sample space. So here, that'll give us 5 plus 5, which is 10. 10 minus 2 on top, that's going to give us 8 out of 11. Now, to make a final comment when it comes to the Venn diagram, okay? The Venn diagram is supposed to contain all possible outcomes in this box, right? The circles contain the outcomes of interest, but the entire box That's our sample space. And as a quick comment, there are some outcomes that are missing in our Venn diagram. So we need to go back and check and see what we were missing from the sample space. Okay, notice the sample space here are the numbers 0 through 10. Okay, so when I go here, I need to make sure that every single outcome is within the box or the Venn diagram, the sample space. So here we have 0, 1, 2, 3, 4, 5. I don't see 6. And notice 6 is not an outcome of interest in A or B. So you're going to leave 6 still inside the box, outside the events. Here we have 7. We don't have 8, so we want to make sure we have 8 inside the box as well. Here we have 9. And the last element in the sample space, 10, we want to make sure that 10 is also in the Venn diagram.